Hello everyone, welcome to my channel. Today I'll talk about ideal gas law via interactive learning. Here I'll discuss Boyle's law, pressure volume relationship. Then I'll talk about Charles law, volume temperature relationship. Then Gay-Lussac law, pressure temperature relationship. Combined gas law, all relationship together. And then universal gas law, PV is equal to nRT. Now here you have to remember key assumption for ideal gases. So first one, gas particle have negligible volume, then no intermolecular forces, perfectly elastic collision, random motion follows kinetic theory. Now here for standard condition also you have to remember means STP means standard temperature pressure. So temperature is 273.15 Kelvin and pressure is 101.325 kilopascal and molar volume at T is equal to 273.15 and P is equal to 101.325 kilopascal, that is 22.4136 liter per mole, and standard pressure, that is 1 atm, is equal to 101.325 kilopascal, and absolute temperature conversion is T Kelvin is equal to T degree centigrade plus 273.15. Now next I'll go to the Boyle's law. So Boyle's law, for a given mass of ideal gas at constant temperature, PV is equal to constant. Now if you have to state number 1 and 2, then P1 V1 is equal to P2 V2. So here P is equal to absolute pressure and V is volume occupied by the gas. Now here I'll take you to the interactive calculator. So using interactive calculator you can calculate that any variable. So now you know that for Boyle's law PV is equal to constant for constant temperature. Now interactive calculator here, so you suppose you have initial pressure 2 atm, initial volume 5 liter. So now here you have to choose one. If you want to calculate that volume V2, so you have to supply pressure, final pressure. So here you can see that automatically that volume is that P1 V1 is by P2, so that is 2 into 5 by 4, 2.5 liter. Now if you change here, so you can if you change something like 10, then it will automatically calculate that 12.5 liter. So if you want to calculate final pressure, so that you have to give final volume 2.5, so that will calculate the atm. So here you can play with that interactive calculator, you can calculate anything. So remember this calculator is based on Boyle's law, where that temperature is constant. So here you have to give initial pressure, initial volume, or another is if you mention final volume, then you will get the final pressure. Now here is the key insights. So that the Boyle's law follow the inverse relationship. As pressure increases, volume decreases proportionally, and it is that if you draw the PV graph, so that will give parabola. Real world application: syringe, bicycle pump and diving equipment. Temperature must be constant, so this law only applies at constant temperature. Now here is the P and V versus plot. So this is like a parabola plot. Now if I go for that Charles law, so here for given mass of ideal gas at constant pressure, V by T is equal to constant. So V1 T1 is equal to V2 T2. So here T is equal to absolute temperature in Kelvin. Now here First is the temperature conversion helper. So here if you change the temperature, so you can easily get the suppose this is the temperature in degree centigrade, and you will get temperature in Kelvin. Now based on the Charles law, so this is the interactive calculator. Initial volume 3, initial temperature 300. So now if you want to calculate final volume, so you have to give final temperature, because here that constant pressure. So if you here if you change suppose 500, so your volume will be 2.4 liter. So here calculation V2 is V1 into T2 by T1. So this is the Charles law. Now here are the key insights. So direct relationship, volume increases proportionally with absolute temperature. Linear relationship, that P versus T plot is a straight line through a origin. Absolute zero, at 0 Kelvin, volume theoretically becomes zero. A real world application, hot air balloon, gas thermometer and thermal expansion. And you can see the plot, volume versus temperature. This is the linear plot. So here this is the final state and this is initial state. Now if through this interactive calculator you will see many things. If you change here suppose 6, so you can that the graph will also change. Now going to that Gay-Lussac law. So that is for a given mass of ideal gas at constant volume, P by T is equal to constant. So P1 T1 is equal to P2 by T2. So here P is equal to absolute pressure, T is equal to absolute temperature. So here is the again interactive calculator. So you remember this is the constant volume. So now initial pressure and temperature is given. Suppose 1.5 and initial temperature 500. Now if you want to calculate final pressure, so you have to supply final temperature. So here is final temperature is 450. So based on that, the P2 is 1.350. Now you can change 600, so it will change automatically. Okay, so again if you put some 250, you will get that. And that here is the plot P versus T. This is the linear plot. Now here are the key insight. Pressure increases proportionally with the absolute temperature. P versus T plot is straight line through origin. Pressure cookers, high temperature increase creates high pressure for faster cooking. And car tire pressure increases with temperature during driving. So this is about Gay-Lussac law. Now if I come with combined gas law, so that will be P1 V1 by T1 is equal to P2 V2 by T2, and from that you will get that PV is equal to nRT. So N is the number of moles, R is the universal gas constant. Now here gas state change calculator. So here P1 V1 T1, so this is the initial state, and then another is P2 V2 and T2. So now here if you 6 parameters are there, you can 6 variable, so you have to supply 5 variables and you will get the others. So now here if you want to calculate that variable, so you have to make 0. Okay, suppose if you want to calculate pressure, you have to make 0 and you have to mention this 2, so you will get that. Okay, so here pressure is 0, that it is not, you have to give some value. Maybe here if it is 0. Okay, so okay, that is you can calculate final volume. Okay, now if I want to calculate suppose 5, and if I calculate this is not coming, something 0. Okay, so you have to give something, and here you have to put 0. So here actually it is calculating the volume, final volume. Okay, so V2 is P1 V1 T2 by P2 by T1, so that is 15 liter. Now if you go for gas constant, so here that value of different gas constant, so if you go for unit meter cube kilopascal kilomole Kelvin, so that is 8.3145 joule per mole Kelvin, so that is 8.3145 meter cube, that megapascal kilomole Kelvin, so 0.0083, so that is given. meter cube atm kilomole Kelvin, so that is 82.06. So standard condition I told you, the STP, that is 273.15 Kelvin 1 atm, and molar volume 22.4136 liter per mole. Now coming to the gas calculator. Okay, so here suppose input parameter, that is 1 atm, volume 22.4, the temperature 2073.15, moles 1. Okay, so nothing is missing. So now if I put here, now calculate missing value, so you will see that 272.97 Kelvin, you'll get that. Now here 273.15, now what will be the mole? So you'll get the moles is 0.9995 mole. So you can do that. Temperature conversion is also there. You can that degree centigrade to Kelvin to Fahrenheit, you can do that. So now here if you change that 50, so now what will happen? So 50 degree centigrade is nothing but 323.15 Kelvin is equal to 122.0 degree Fahrenheit. So you can also do that pressure conversion. You can do that. So this is about the universal gas calculator. Now if you go to the practice problem, so Boyle's law. So here the problem is one gas at 2 atm pressure occupied 5 liter. What will be the volume if the pressure is increased at to 4 atm at constant temperature? So you have to use Boyle's law. So Boyle's law is P1 V1 is equal to P2 V2. So from here you have to calculate V2. So you plug all these value, you will get that. Similarly, here Charles law, you can do that. So a balloon has volume 2 liters at 20 degree centigrade. What will be the volume at 100 degree centigrade if pressure remain constant? So here you have to use V1 by T1 is equal to V2 by T2. So from there you can easily calculate V2. Now here is the answer 2.55. Now if you plug that value here and if you check the answer, you will get the answer. So that is 2.55 liter. So these are the good, if you have if you have the answer, you can put that and you can check that. Now intermediate level, you can go here. So suppose combined gas law, gas sample at 1.5 atm 300 Kelvin occupies 4.0 liter. Calculate the final volume when condition changes to 2.0 atm and 400. So now here you have to use like P1 V1 by T1, P2 V2 by T2. So from that you can easily calculate V2. Plug all this value, you will get the answer. V2 is 4 liter. So now here you can plug that, so you can correct, well done. So you can check your answer. Similarly, universal gas law. So how many moles of the gas are present at 10 liter container at 2 atm 25 degree centigrade? You can do the calculation. PV is equal to nRT. So everything is given. So you can calculate N. So now here N is something 0.186. So you can, if you put the wrong answer, that correct is 0.16. Not quite right. Try again. So these are the means question and answer. You can check your answer. And advanced levels also you can do. So Dalton's law, you know Dalton's law, that parts total pressure is equal to sum of all partial pressure. So that way you can also do that. That's it. Thank you.